Hello, I welcome you all in this course on steam and gas power systems. We have already discussed different kind of boilers. Today we will discuss about boiler mountings and accessories. Now boiler mountings are integral part of a boiler, of any boiler. Without mountings, a boiler cannot work or boiler cannot function. However, without boiler accessories, boiler can work, but maybe with a relatively lower efficiency. So first of all, we will discuss about the boiler mountings. Now the first and the foremost thing in a boiler is a pressure gauge. Because we must know what order of pressure is existing inside a boiler. So in a boiler, the pressure gauge is fixed on the shell. It is a dial type pressure gauge. Nowadays digital pressure gauge are also available, and pressure transmitters are also available. Their pressure transmitters are simply transducers, and signals are sent to the display unit, right. But a dial type pressure gauge is a must. Even in this case, this type of dial type of pressure gauge is a must, and this pressure gauge displays the pressure in different units. If you go to the industries, you will find pressure in kilogram force per centimeter square. This is typical of MKS system of expressing the pressure. You can find pressures in kilopascal, megapascal and PSI, pounds per square inch. Now pounds per square inch is a inch pound system of pressure measurement. This is MKS system and this is SI system which we follow. But if you go to the industries, you will find that because these equipments are purchased maybe 30 or 40 years back, this type of pressure gauge display with this one and maybe pounds per square inch also, right. So you have to be very conversant with the units, conversion from this MKS system to SI system and IP system to SI system. Now after the pressure gauge is water level indicator. Because when the boiler is in operation, the operator must know what is the level of water in the boiler. And the arrangement of water level indicator is very simple. In order to find level of water in the boiler shell, suppose this is a boiler shell, and I want to know the level of water in the boiler shell. This is closed. So this is the level of water in the boiler shell. A pipe is connected from the top and the bottom, and at the end of the pipe there is a glass tube. I am showing you only schematic arrangement. In actual arrangement you will find a valve here, you will find it's not that simple, right. But here I am giving a schematic representation so that you can understand how a pressure level indicator works in a system. So this is attached to the system. Here there is a valve to close supply, here also there is a valve, and this is a glass tube, right. So whatever level is there, because water will like to maintain the level, so this level can be displayed here also outside the boiler. So the operator can see what is the level of water inside the shell. This may not working as long as the boiler is working. You may close these valves, and whenever you want to see the level, you can open the level. This can also be done. But the problem is, suppose this tube breaks, all the steam or all the fluid inside the container will come out, because this is high pressure fluid. So entire fluid will come out of the system. So in order to prevent that, balls are provided, steel balls are provided, ordinary steel balls are provided, and the moment the fluid comes with the pressure, these balls they close these openings, so the fluid does not go out, right. So the basic function of the water level indicator is to show the level of water in the boiler. A boiler has safety arrangements also, because the water at high pressure contains a lot of energy in comparison to the other fluids, right. So, safety measurements, safety precautions have to be taken, and for the purpose of safety at least 2 safety valves have to be provided. There are 4 types of safety valves. Now, safety valves, there are 4 types of safety valves. One is dead weight safety valve, dead weight safety valve. The second is lever safety valve. Third is spring loaded safety valve, and the fourth is high steam low water safety valve, high steam and low water. High steam means high pressure of steam, high pressure steam or low level of water. Now, these safety valves are fixed on the boiler shell. Dead weight safety valve. Now, dead weight safety valve consists, of course, as it implies from the name itself, it consists of dead weights. Suppose there is a passage of steam and this is connected to the boiler shell. Now, through this passage the steam is coming and there is a closing arrangement for this and there is a housing. So, the steam in the boiling shell, when pressure exceeds the working pressure or the pressure we have decided for the boiler to work, in that case this steam exert force on this closing body and it opens the valve, this entire body it lifts, as you must have seen in the pressure cooker. When the pressure exceeds to from a certain limit, the vessel of the pressure cooker it lifts, the steam is vented off. In same fashion it works. There is a provision for putting weights, because you may like to vent steam at different pressures for different applications. So, you can keep on adding the weights, and operating pressure for this safety valve will keep on changing. It is very simple in construction, and it is very convenient to operate. Now, the another valve is lever safety valve. Lever safety valve is almost like a dead weight safety valve. In this valve, suppose there is a passage again and this side is filled with the steam. It has a lever, that is why it is called a lever safety valve, and this lever arm, on this lever arm on the extreme side there is a dead weight in lever safety valve. Now, this dead weight, it is hinged here, and this again is connected to a system which closes this opening. Now, again, if the pressure is exerted on this, the steam will push this closing body, and this is also a body of the valve. Right, and because it is hinged here, this weight will be lifted and steam will be vented off. Now, I want to operate this lever safety valve at different pressure. Suppose I want to operate it on reduced pressure. Instead of venting off steam, let us say 10 bar, it should vent steam at 9 bar or 7 bar. Simply what I will do, I will shift this weight to this place. So, manipulation is easier. In dead weight safety valve, you will have to insert the weights. Here simply you have to pull it and shift it to another place. There are grooves on the arm, and by shifting this weight you can monitor, manipulate the working pressure of this lever safety valve, right. The third one is spring loaded safety valve, because in safety valve always a balancing force is required. In dead safety valve it was the weight of the dead weights which were put on the wall. Here instead of putting weight, spring force is used for controlling the opening of the valve, and valve may come in different shapes. I am taking a particular shape, but they may come in different shapes. This is a U type system. On the both sides the valve is closed and steam is coming from this side. Steam I will show with blue pen. So, steam is coming from this side, right, and here there is a spring type of arrangement. Sorry, it is. Here there is a spring. So, when the pressure is exerted on these two openings, right, these two closings, right, then they open, they are lifted from the seat and spring is stretched, right, steam is vented off, and when the pressure is reduced, the original position is restored, because spring it pulls back these stoppers to the original positions, right. This is how it operates, and tension in the spring you can control from here. There is a nut and bolt type of arrangement, there is a nut, you just simply tighten that nut, the tension of spring can be manipulated, right. So, it can have this shape, it can have another shape also. Another type of arrangement of spring loaded safety valve, it is something like this is the boiler shell, this is opening, this is stopper, right, above it there is a spring, this is valve housing, from here the exit of the steam is taking place, there are flanges. So, when the steam exerts force on this stopper, again it is lifted and steam is vented off through this opening. So, there can be many arrangements. The working principle is the pressure of steam is balanced with the help of tension in the spring, right. Now, the fourth one is high steam and low water valve. Now, high steam, low water valve, it serves two purposes. First is when the pressure of steam is high, steam will be vented off. When the water level is low, right, in that case also some indicator has to be there, so that operator who is sitting in the operation room may know that there is a low level of water, right. So, in this type of valve, there is a boiler shell, wall of the boiler shell, and there is an opening. This is a semi-circular disc, it is connected, it is exerting force on a lever, there is a lever again, this is the counterweight W, here there is a float and it is hinged here. This lever is not hinged here, it is hinged here, right. Above this again there is housing and provision for steam to vent, and again there is a stylus here connected to the dead weight type of safety valve. Now, what happens? Suppose the water level in the boiler shell goes down. When the water level goes down, this float will also come down, because it will be floating on the water surface. So, this float will also come down. When the float comes down, this arm of the lever will twist and this will cause opening of this disc, and steam will escape from here, and it will give a different kind of sound, and this sound will be distinct from the normal steam venting. So the operator can easily identify that the water level has gone down. Another device is water level indicator, but water level indicator you have to monitor, always monitor, you have to watch that, or a operator has to watch whether water level is going down or not. But here in this case, when the float is settled on the surface of the boiler, or the water level goes down below a certain level, in that case this opening will vent off steam and it will come out with a different sound, right, and the operator will come to know that water level has gone down. On the other side, suppose the pressure exceeds, because this shell is partially filled with the water and partially filled with the steam. Suppose lower part is filled with the water, definitely lower part has to be filled with the water, and upper part is filled with the steam. Pressure of steam exceeds. Pressure of the steam exceeds the design pressure. Now in that case, this force will be exerted on this disc, because this will exert force on the disc, this disc will open, and this arrangement is a sort of deadweight safety valve type of arrangement, and again the steam will vent off, but this sound will be different from the previous sound. So the operator will come to know this is the normal venting when the pressure of the steam is high, and this is the venting. In the previous one was the venting was the sound of the venting steam when the water level was low in the boiler, right. So these are 4 safety devices, and it is recommended at least you should have 2 safety valves in the system, because safety valves have a very important role to play, because if safety valve fails, accident may happen. So that is why for the safety purpose, any two of the safety valves are recommended to be put on the boiler mounting, as a boiler mounting. Another safety device in the boiler is fusible plug. Now fusible plug, they are small, very small in size, and they are used in fire tube boiler, and they are put on the surface of the fire tube, right, and these plugs have fusible material. They are filled with the fusible material, means the material which melts at high temperature, right. So when the temperature exceeds from a certain limit, the material filled in this fusible plug melts and water enters the grate, and the fire is extinguished and accident is prevented. But in this case, the boiler will shut down. I mean, it cannot be it cannot operate in a running boiler. Once it is operated, this fusible plug is operated, the fusible material, it has a copper cap also, right. So when the material is melted, the water will enter the fire tube, it will go to the grate, or it will take away heat from the fire tube, right, or the flue gases flowing in the fire tube, and ultimately the heating in the boiler will slow down, or it will be reduced, right, and in that case the accident can be prevented. But when this becomes operative, we will have to restart, we will have to replace this fusible plug with another fusible plug, and then the boiler can be restarted. Now after fusible plug, there is a steam stop valve. Steam stop valve. Steam stop valve is a normal valve to take steam out of the boiler. As we have valves in the containers to take water out of the container, in similar fashion there is a steam stop valve which is connected on the boiler. Again there is a disc which closes this opening, and disc is operated with a arm operated wheel, right, and this keeps disc in the place. This is the housing, and from here you can get the steam. So sorry, this should be outside this. This has to be outside of this housing. So this has to be outside this housing, and is mechanically fixed to this. Now simply when the steam, if you want to steam at any moment from the boiler, simply turn this wheel, this rod or this stylus will rotate, and this which is closing the mouth of this opening will open up, and steam will flow from this passage and will come out of the steam stop valve. It is simply a steam supplying valve. It is a steam supplying valve, and closing and opening arrangement is same as in the case of normal water supply valve. Okay. And this valve is also placed at the highest point in the boiler, because steam is accumulated at the highest point in the upper half of the boiler, right. So, it has to be placed at the highest point of the boiler. Another valve is feed check valve. Now, in feed check valve, its construction is almost same. I can explain with this figure only. Now, feed check valve is a valve like this. It is a non-return valve, and it is fixed at the supply line of water supply line. So, when the water is pumped into the boiler, it passes through feed check valve. When water pushes this disc, the disc opens and the water is passed through this passage. This, when water, suppose water is flowing here, it is coming from the pump, right, and it is put in series in the supply water line. So, this side is closed. So, water will push this disc. This disc is simply resting on this body. It is not connected to this stylus. So, the water will push this disc in upward direction. The moment this opening, through this opening, the water will come out of this valve. And why it is non-return valve? Because because we have to use a non-return valve in the case of feed water supply, because when the boiler pressure is high, there will be a tendency for the reverse flow. So, when the flow is reversed, this disc will fix on this seat, and it will prevent the reverse flow of water from the boiler shell to the pump, towards the pump size. So, this type of valve is a feed valve. In addition to this, a boiler has a manhole. The function, or it is a simply hole in the boiler shell or in the body of the boiler, just for the inspection and maintenance purpose. A boiler has blow off cock. Blow off cock is placed in the bottom side of the boiler. This is blow off cock. And the function of the blow off cock is to remove the sediments and the impurities from the boiler, because during hours of operation of the boiler, sedimentation takes place in the boiler. So, intermittently this blow off cock is opened. It is a simple valve, is a type of gate valve, something like this. So, when this opening is turned, is in line with the supply of the line of the supply, the valve is opened, and the sediments and the impurities are removed from the boiler. After this, we will take up the accessories in the boiler. Now, accessories in the boilers, nowadays they are necessary, because we want to have higher efficiency of the boiler. If you want to attain higher efficiency of the boiler, accessories are necessary, and the accessories are: number 1, superheater; number 2, economizer; number 3, air preheater; and number 4 is steam trap. Now, superheater means steam superheater, because we need superheated steam in order to have higher efficiency, because when you superheat the working fluid, then average temperature of heat addition increases, and this imparts the higher efficiency to the cycle. So, for superheater, normally in a shell, you must have seen in the previous lectures also, steam, because in shell there is a mixture of liquid and vapor. So, steam is taken from the shell, and again it is put to the grate or in front of the flue gases, so that it picks the heat from the flue gases and superheated steam is available for the use. So, the superheater works, it is a simply arrangement of the pipes, the steam is saturated, steam is taken from the shell and it is recirculated in the grate also. When it is recirculated in the grate, it is known as radiant heating. So, superheating can be done by two ways, either convective heating or radiant heating. Radiant heating is done because in the grate the temperature is very high. So, heat transmission to the working fluid is through the radiation, majority of the heat transfer, right. So, that is why it is known as radiant heat transfer. And then after radiant heat transfer, the tube can have heat, they are simply heat exchangers. So, the working fluid can exchange heat with the flue gases also, because flue gases are at higher temperature. So, that is known as convective superheating. So, radiant superheating and convective superheating. The purpose of superheating is to improve the efficiency of the cycle. So, nowadays in modern boilers, the superheaters are also an integral part. Another is economizer, because in a boiler a lot of heat goes out with the flue gases. So, our objective is as an engineer to trap as much as heat is possible from the flue gases. So, superheater is also doing the same job. Now, same job is done by the economizer. In economizer, the feed water which is going to the boiler, it is heated. So, if feed water is heated, if you look at the Rankine cycle, this is feed water, this is high pressure feed water. If we heat this feed water, then in that case net temperature of heat addition will also increase, or less heat will be required in the boiler. Either way we can say, less heat will be required in the boiler, right. So, and this heat is coming from the flue gases, so it is coming free of cost. That is how we are increasing the efficiency of the boiler. So, this is the function of economizer. Now, another one is air preheater. Now, the air which is going to the grate, it is surrounding air which is going to the grate for burning the fuel. This air is first circulated before the flue gases. So, it takes heat from the flue gases, and when it takes heat from the flue gases, the temperature of this air rises. That is why it is known as air preheater. So, air preheater is also a heat exchanger. Economizer is a heat exchanger. Superheater is a heat exchanger. And purpose of these accessories is to increase the efficiency of the cycle or efficiency of the boiler. First of all, the efficiency of the boiler, right. If the efficiency of the boiler is increased, the efficiency of the cycle will automatically increase. So, air preheater also takes heat from the flue gases, economizer also takes heat from the flue gases. Superheater is again, it takes heat from the grate and the flue gases flowing in the boiler. In addition to that, there is a device which is known as steam trap. Now, what happens when there is a flow of steam in a pipe? Pipes are insulated, but no insulation is perfect insulation, right. So, in that course, when steam is flowing in the pipe, some condensation will take place, right, and this condensate will get accumulated, will keep on accumulating in the pipe. If we do not remove this condensate from the pipe, it will start choking the pipe. The condensate will be accumulated in the bottom of the pipe, and if we do not remove the condensate from the bottom of the pipe, it will keep on choking the pipe. So, a steam trap is provided. The function of a steam trap is to remove the water in the mixture of steam water mixture. Okay. It removes the water and steam is let go. There are different type of arrangements, right, like flow type steam trap, reverse bucket type of steam traps are also available, bucket type steam traps are also available, but the function of all this steam trap is to remove steam from the flowing steam. That is all for today. Now, in the next class we will start with the high pressure boilers.